In Chapter 2, we'll start to get a little more detailed about pieces of Swift, common building blocks like strings and functions, structures and classes, which are the main ways that we represent custom forms of data that we're going to need. And we'll find that there are some key differences between structures and classes, and structures in this language are much more powerful than elsewhere. So between a structure, as we often call them, a struct, and a class, there's actually a much closer comparison than perhaps we might elsewhere. We'll also see the idea of collections, things like arrays. Think of these as boxes to keep data in. And loops, when we're going to do something repetitively, a loop is a way for us to do that where the number of times we do it changes each time, and we can also put the code in there once and just have it repeat as necessary. Later on, we'll start to build out more things from UI Kit, starting with the very simple ideas you saw in the last chapter and how we can use other things that can be outlets, can generate actions, how we can display data in other ways than the simple way we saw in Chapter 1. Some of the other controls, but also different ways to make things look good, especially on all device sizes, using auto layout, where it will lay out your elements based on what the available size of whatever device it's running on happens to be, and that includes simulators, and stack views, which if you have things that are set up in a very linear fashion, stack views can be a very convenient way to go about it. In this first video, we'll just talk about the first two bits of Swift, strings and functions. So what we're going to see is that strings are used a ton in a variety of different languages. And again, you can read more in the Swift Programming Language Guide. What we're going to find here, and again, if you've programmed before, you've seen strings, and we mess with them a little bit in Chapter 1, where there's some set of text between quotes. And as we saw in Chapter 1, we can have constants with let, variables with var, and that here we can just assign, because remember, because of type inference, since the thing we're assigning to them is string, they will both be typed as string for the extent of their lifetime. And again, that's something called static typing, sometimes also known as strong typing. So again, we know that we can't reassign if it's a let. We can do empty strings where if, say, maybe my string is something that's coming later, but I need to declare it here, and I want to get the type inference that it's going to be a string, you can do that, which is just I'm an empty string. Also note that we're going to see strings have properties and also methods. Also sometimes we'll have things that look like properties, look like things that belong to an entity, but actually are generated in code. We'll see those later. It's a really important concept in Swift called a computer property. But note that this is an instance property. It says for any particular string variable you have, you can do dot and then say is empty. That says an empty has only been computed once. It just says, hey, for any string, whatever string is over here, I will look at it and be able to tell you, and note that's a Boolean, true or false, whether it's empty or not. And we know in if statements we use Booleans. So it can say, well, I can do something conditional based on whether or not a string is empty, and I don't have to figure out whether the string is empty. The string can tell me that. String concatenation, if we want to put two strings together, the plus operator is overloaded. We'll see in the future, and this is a fairly advanced idea, that you can overload operators yourself in Swift. It's very interesting. Where here I'm going to say that the plus, if I'm working with two strings, is not arithmetic addition, but it's concatenation. I put one string on the end of another one. Concatenation. String interpolation is something in Swift, and the name is fairly unique to Swift, but not completely, where if you want to print out not just raw text, but the current contents of a variable, you use a backslash and parentheses around the name, like we have either a name or an age here, and that will print out the current contents of the variable. And note that that will handle a lot of fairly standard formatting for you, and it's a less laborious way than we see in a lot of other languages. If I want to find out if two strings are equal, well, good news, it's the same relational operators that we saw before. And you may have seen other languages where equality of strings is handled differently, but here it's pretty straightforward. It just says, hey, do each of these have the same characters in the same location? Are they basically the same string? Note that they can be two distinct strings that just have the same contents or the same state. Swift also handles the built-in not equal to for you, so that's very convenient. If you want to do what we call a case-insensitive comparison, where you can say whether something is upper or lowercase, I don't want to have that come into consideration. I just, I want both upper and lowercase j to be interpreted as the same thing. The way you handle that is you take the strings and you get copies of them that are in a common case, and commonly it is going to be lowercase. So note, here's a call to a method called lowercase. So what this does not change the name string. And remember, with name being a let, it couldn't be changed anyway. What named lowercase is going to do is lowercase says, okay, I'm doing this with name. I'm going to make a copy of name for you, and any uppercase letters will be converted to lowercase. So what you have over there is a copy of the string. And over here on this string, and note that this is a literal, but it is a string, so we can call methods on it. It says, oh, okay, well, I'm going to take a copy of that string as lowercase, and then we can do those. So often when you're looking for things and you're working with strings, it's a good example because often we do case-insensitive comparisons. But there's all other handy things where in other languages you may have to write a little more code to do this, where has prefix, saying, does this string start with that? And that could be a string of any length. Or does it end with that? And note that the last one there is false because remember, we're going to be case sensitive unless we tell it otherwise. So note that's a capital W, that's a lowercase w, that's why the last comparison is going to be false. Contain says, does it have it, but as opposed to prefix and suffix that can be anywhere, this says, well, it can be, at the beginning or the end specifically, this says, well, it can be anywhere. Here, note that a string you can do something called count, which says how many characters are in the string. This is often very important, sometimes referred to as the length, but we're going to see also when we work with collections later in the chapter that count is what we use in Swift. Note that you can also have characters and check those. And again, I would recommend looking at some of the string topics if you want to use them as well. You may have seen ASCII. Swift, like Java, uses the Unicode character set, so that gives you a wide range of different characters. And like we saw, emojis, not only for variable names, but can be used in strings as well. So there's a lot of interesting options available to you in the language. But other than that, strings are pretty straightforward, but we use them a lot, so we want to make sure that we have things down, and also to get you to start investigating a little bit as you do when you work with the Strings Lab. So to talk a little bit about functions, we want to identify individual tasks, especially if they might be called more than once. Rather than writing repeated code, we want to write a function. We want to write a function in isolation, that a function will get whatever it needs, do whatever it needs to, and return whatever it needs to return. I often call this the honey badger philosophy of function writing, meaning if you're familiar with the meme of honey badger don't care. Function don't care what happens outside the function. And if you keep this in mind, you're going to find that scoping and writing your functions, getting your head around them, is going to be a lot easier. Sometimes people, when they first write functions, make it way more complex than they need to. The idea is that a function will receive and request whatever data it needs in the form of what are called parameters, does its work, and will return a value. And also because of this, these methods can be very short. Think about an example of a very short method, the action method that we saw in the example and you did for the lab last chapter. That said, here's something I want to do when a button was pressed. It received the button, although in this case, just the fact that the method was called, and we call functions and methods usually the same term interchangeably, although Apple does prefer to use function here. By calling that, we know that, we needed to do something. We did the code that we needed to do because the button was pressed, and then we left. And we're also going to find that in a lot of functions, or when we're doing things involved with events, we aren't necessarily passing and returning data in a more common way. So what you saw with outlets and actions is a little bit atypical, and we're going to see both forms being used quite a bit in iOS. So what we want to show you are some of the syntactic options that are available in writing a function in Swift. First of all, you may not have this in other languages. You actually start with func, and then the name of the function. And if you work with other languages, often the return value goes there, but we're going to find the return value goes at the end. We have the parameters, and then if it is returning something, we use the arrow, the minus and the greater than, and then the return type. If you have a method function that doesn't return anything, or what we commonly call a void function, you can skip all that. You don't have to go arrow void if you don't want to. Between the brackets are the body of the function or what we want to do. So we can call different functions. Note that you don't have to have parameters. Like in the case of tie my shoes, it just says the fact that you call tie my shoes, okay, I know what to do. I don't need any additional information. Nothing needs to be provided. On the other hand, make breakfast, and this is something we'll see later in the chapter, an array that says, hey, I want to make breakfast with everything. I'm going to provide you a list of things I want to make for breakfast. DisplayPy, note it doesn't return anything because it prints out, and sometimes, usually our void return functions, not always, will be about output, although generally we don't mix output and another task in a function. We keep those as two distinct functions. So DisplayPy says, okay, I don't need any information because I already know what pi is. And remember, like we saw last chapter, there's a pi value that's available to you that you can use. I just need to display it. But often we're going to need one or more parameters that says, I want to do something, and what I'm going to do it with is different each time. It's a variable, and that's fine. We can write the function. So instead of writing code specific to a bunch of different situations, we can just isolate the common logic in a function and call that whenever we need to. In the case of triple here, this says I'm going to triple some integer value. Now, what value that's going to get printed out, which is tripled, will be dependent on what value is being passed, but how we do it doesn't change. So we don't need more than one set of code to do that. But since the value is going to change, we're going to need a variable. And note that a parameter is a variable. And what we'll see is what we call a local variable. It's local. It only belongs to the function. And the great thing about this with parameters is you can pass in, as we'll see in a moment, arguments that relate to that specific call to the function. And whether that value has a name or where it came from, we really don't care. Because when the argument gets delivered to us, it's dropped in an inbox, in this case called value. So when triple gets the knock on the door and says, hey, triple, you need to do something, it will open up the value box and say, okay, what did they leave for me? Okay, whatever that is, again, I don't know where it came from. It showed up on my doorstep. I'm calling it value. So it gives you a lot of flexibility. You don't have to worry about the name. And when you call something, you don't have to worry about having arguments that have the same name either. So this is whatever value I got this time, always multiply it by 3 and print it out. So that's part of it. Is the thought process is really what you want to think about. Here, multiply says the same thing. I'm just going to multiply a couple numbers and print them out so I can have two parameters. And note that we do this, we do have to say what specific type we're looking for. So here we are saying the name of the parameter, colon, followed by the type of value. And this is where we pass in the arguments, where we say, I'm calling multiply. Multiply says, hey, I'll do this for you, but you need to provide me a first number and a second number. And while this might seem a little laborious, as you may have already noticed, Xcode is really nice on autocomplete. So it'll actually do the labels for you. You just need to type in the values or the variables that have the values for you. So this says, and note that this is really easy to read too. It says this is going to be the first number, this is going to be the second number. So when we call multiply, 10 will get assigned to the first number parameter. The 5 argument will be assigned to the second number parameter, the end. And these involve something called argument labels, where you have in here what is the name, so that when you do it, you're expected to provide that label. But again, like we said, Xcode will do you a solid and handle that for you. But you also have the option where you could say, well, I'd like it to be to and to make it more readable for the caller. So you could do it that way. But here's another nice Swift option. This is something that goes back to Objective-C that says, hey, you know what we can do is we can have different names that the caller uses, but if I want another name internal to the method that is more specific to me, but maybe not as labor intensive for the caller, I can do that. Where here, note that the first parameter is known inside the function as person, but the argument label you need to pass it is just to. And here, the parameter name inside the function is called another person. Here's and. And you can decide whether you want to use this or not. But as you start working with some of the framework methods that Apple provides, you are going to see some examples where they are going to use this. So you want to be familiar with that syntax, whether you use it or not. And note where they mentioned over here that if you said, well, you know what, it's kind of implicit what you want me to do. So I don't want to clutter things up or force people to pass an argument label, if they don't need to. So this is another option in Swift that says, well, I need a name to use it inside the method. It's person, but if I use underscore, when you call it, and note that these both have underscores, you do not provide argument labels. It just says, hey, I need to say hello to those two. It's pretty obvious. We don't want to type person another person and clutter that up. The other thing, and we'll see this later on when we start working with loops too, is that underscore is a common thing in the Swift language for, I know I need to account for something, but I'm not going to use it, or I'm not going to give it a name. And this says, I'm giving them a different external option, but it has no name because they're not expected to type anything. You can also give people the option to say, well, maybe they don't have all the arguments, or they will accept our default. That's where we can have default parameter values that says, here's a string that I have to have, but an integer that I'd like to have, but if you don't give me one, I'm going to assume the score is 0. So note here, if we call it and we pass both arguments, as you would figure, they'll get assigned to team name and score respectively. But you also can just say, I'm going to call just with the team name. I didn't provide an argument for score, so I used the default value instead. The other thing we want to look at are return values. And that says, generally, if we're doing something, we're expecting a result back. Like in the case of multiply, we don't know if people are going to want us to do some operation like a multiplication or addition or whatever for us that they want output. They may just want the answer. And again, that's part of going back to Honey Badger. We're here to do a multiplication. What they're going to do with that, we neither know nor care. We'll give them the value. If they want to print it, they can do it the way that they want to do it. Because also if we output it, it's really hard to know how everybody would want to use it. We want to make our code as flexible as possible. So instead of having multiply print out, we'll add a return value and say, if you call multiply, we'll give you back an int, and you can do whatever you want with it. So we can flesh that out and say, we'll generate the result, and then using the return keyword, we'll kick it back, because if we have a return of int here, the compiler is going to look at this and say, hey, no matter what happens here, you've got to return an integer. And note that based on type inference, the result will be an integer. It says return that back. But what you want to do, and this is a good coding practice, is there's really no reason for the result variable at all. So you can go back, and again, maybe you do this at first, and that's fine. And you come back and you do what we call refactoring. We come back and we change, we improve our code. We streamline it. And it says here, well, you know what? As soon as I do that multiplication, I'm done. That would be like somebody say, do this thing and put it in a box. Okay, now what? Take the thing out of the box and give it to me. To which you'd say, well, why don't you just have me give it to you to begin with? And I'd say, well, yeah, exactly. So here, note that we're going to take the two parameters, we're going to multiply those together, and as soon as we have the result, our work here is done. Just return the result of that multiplication. There's no need for that intermediate variable. And often if you have a variable that's only being used once, what I like to call a single-use variable, that's usually a real likely target for refactoring. So here, note that we can call multiply, we can pass in the two values, and remember it's assigning an integer back, because remember we have an integer return value. So it says, give me the value returned when I call multiply with those things and assign to my result. And note that's a declaration of my result, which is now going to be inferred to be int, because that's the return type of multiply. And again, you could also inline the call right into the print statement. And again, that's another case of whether it's single use or not. Am I going to use my result after I print this out or not? If I'm not, I'm probably just going to do this. Just print out the value for me. So some really good ideas to think about with strings and functions, things we use quite a bit. In our next video, we're going to talk more about how we can create data types. Even though we've seen some good, helpful data types, we're going to need some way to gather information into some form that really suits whatever app we're doing. And we're going to find that structures and classes are our two primary ways to do that. We'll start to contrast those. There's a lot to look at there. We'll also talk about the idea of value types and reference types. That's a big Swift thing that we want to start talking about. And we'll get to that in the next video.